Okay, so there is this question which was on the tutorial sheet under back titration. The question is reading as a 0.205 grams sample of calcium carbonate with the relative molecular mass of 100.1 gram per mole is added to a flask along with 7.50 mils of 2.00 molarity hydrochloric acid. Then we are given the first equation, which is this one. So this is the reaction between calcium carbonate and the hydrochloric acid, which produced calcium chloride, water, and the carbon dioxide. Now, they are saying enough water is then added to make a 125.0 ml solution. A 10 ml aliquot of this solution is taken and titrated with 0.05.8 molarity of sodium hydroxide. Then there is an equation which shows the reaction between sodium hydroxide and the hydrochloric acid. Now, just correcting the data, they are saying calcium carbonate had 0.205 grams. Then apart from that, we also have the mixture, which is 100.01 gram per mole. Then apart from that, we are given the data about hydrochloric acid, which is equal to 7.50 mils with 2.00 molarity. So instead of me writing molarity, I'll just say mole per liter. Okay, so this is the data for the first equation. Then for the second equation, they are saying a 125 solution was made when enough water was added, which means from this solution, from this reaction which is here, more water was added. But there is something that we have to understand on this one. What is that thing? If more water was added, then the reaction between these two was not affected. What was affected is the substance which was in excess. In this case, we don't know which one is in excess, but they are saying the 10 mils aliquot of this solution is taken and titrated with sodium hydroxide. From the second equation, we can see that there is hydrochloric acid, which shows that from the first reaction, hydrochloric acid was in excess. Then the question is, how many mils of sodium hydroxide are used? So the best thing to do here is, first of all, you have to know the excess amount of hydrochloric acid which was here, and that excess amount of hydrochloric acid is the one which took place in the second reaction. Therefore, we will use calcium carbonate to calculate the number of moles, and we will calculate the number of moles of hydrochloric acid which is present. So we will say, we know that number of moles is equal to mass over mixture. Then mass is 0.205 grams, which is divided by the mixture. So the mixture for calcium carbonate, they are saying is 100.1 gram per mole. Then from there, we can able to see that when we divide these two, we're going to get 0.002047952 moles of what? Calcium carbonate. If this is the number of moles for calcium carbonate, then we will calculate the number of moles for hydrochloric acid, which is here. Now they are saying there is 7.5 mils of 2.00 mole per liter. In this case, we know that number of moles will be found by multiplying concentration and the volume. So what are we going to do? We know that concentration, which is given there, is 2 mole per liter, which is being multiplied by the volume, which is 7.50 mils. So this one is in mils, but we have liters here. So in this case, we just say times 1 liter divided by 1000 mils. So this mil and this mil will cancel. This liter and this liter will cancel. Then we are going to remain with a number of moles here. So when we do the calculations, we find that the number of moles is in 0.015 moles. So this is for hydrochloric acid. So let us not forget, this is the number of moles for hydrochloric acid that are present. So we will say this one is present, this one is also present. But since from the equation we know that this was in excess, therefore let us just calculate the number of moles which was used here, or which reacted with calcium carbonate by using the mole ratio. So looking at the mole ratio, we know that the mole ratio is 1 to 2. So if the mole ratio is 1 to 2, then we know that this side we have calcium carbonate, this side we have hydrochloric acid. Then the number of moles for calcium carbonate is 0.0022. We don't know. So we are trying to calculate the number of moles. In this case, we'll cross multiply here. Then we'll say number of moles is equal to, when we multiply this, it is going to give us 0.004 moles of HCl that reacted. So this is the number of moles of hydrochloric acid which reacted. Then after seeing that, we have to know the number of moles which was in excess. We have to know the number of moles which was in excess. But how are we going to know that? Simple. We will just say, since there was a presence of 0.15 moles of hydrochloric acid and only 0.004 moles reacted, then we will say, for us to know the excess, we will say present minus x reacted. So present was, so we'll say subtract here. We'll subtract. So we'll say 0.015 mole minus 0.004 mole. So when we do the calculations, okay, we find that it is 0.011 mole of hydrochloric acid in excess. This one is in excess. So we have found this in excess. Then from there, what are we going to do? What we are going to do now is, since we have known the number of moles which are in excess, but looking at the question, they are saying enough water is then added, which means the number of moles which was affected is this one. To what volume? 125 mils. Therefore, we have to know the concentration, because why are we supposed to know the concentration? When you add water, you are diluting, but you are maintaining the number of moles. In this case, we know that concentration is equal to number of moles over the volume. In this case, concentration is equal to number of moles, which is 0.011 moles, divided by the volume, which is 125 mils. Now, this is in mils, so we have to get rid of these mils. Therefore, we'll say times 1000 mils divided by 1 liter. So this one is just a conversion factor of mils to liters. So this mil and this mil will go. Then the concentration will be equal to 0.088 mole per liter. Then after calculating this concentration, which is here, this is not the concentration which was used. So they are saying 10 mils aliquot of this solution is taken and titrated with. So it means that out of this concentration, only 10 mils was gotten. So we have to calculate the number of moles which were present in that 10 mils out of this concentration. In this case, we are going to say, since the number of moles is equal to concentration multiplied by volume, then we will say, what is our concentration? Our concentration is 0.088. Then multiplied by, so let me just show the units. Being multiplied by the volume, which is 10 mils. So we want to get rid of these mils. So 1 liter divided by 1000 mils. So this guy and this guy will automatically go. So what are we going to remain with? We will remain with our number of moles, which is, let me calculate. Okay, which is 0.00088 moles of what? Hydrochloric what? Acid. So this is the number of moles of hydrochloric what? Acid, which did what? Which further reacted with sodium hydroxide in the second equation. So they only used 10 mils Yeah, 10 moles. So this is the number of moles that we have. Then from there, since we have calculated the number of moles, the question is not talking about the number of moles. It is talking about the concentration, I mean the volume, and that volume must be in moles. Therefore, since we have the number of moles and we are given the concentration of sodium hydroxide, then this one, for us to know the number of moles of sodium hydroxide, we will come back on the second equation and look at the mole ratio. So the mole ratio is 1 to 1. So the mole ratio is 1 to 1. Since the mole ratio is 1 to 1, which means the number of moles for hydrochloric acid are the same number of moles for sodium hydroxide. Therefore, we will not waste any time here. So we will just say, volume is equal to number of moles over concentration. And what is that? Number of moles is 0.00088 mole divided by the concentration, which is 0.058. According to the data, we have mole per liter. So this guy and this guy go. Therefore, we are going to have our volume as 0.015 liters, but we don't want our volume to be in liters. Therefore, we will multiply it by the conversion factor, which is 1000 mils divided by 1 liter. So liter and the liter will go. Therefore, we are going to finally have our volume as 15 mils. So 15 mils. Okay. Now, sometimes you might not even want to waste much of time. The moment you calculate the number of moles which are in excess here, you can even say, since you have known the number of moles in excess, you can just say, since they used the 10 mils out of 125 mils, which was summed up, then times the number of moles which are in excess, which is this one, 0.011. When you do the calculations, we will find that. Let me. Okay, so the answer is 0.00088 moles. Then this one is for hydrochloric acid. Then we know the mole ratio is 1 to 1, which means this is the same number of moles for sodium hydroxide. Then we go ahead and bring it here by saying volume is equal to 0.00088 mole divided by 0.58 mole per liter, which is giving you 0.15 liters being multiplied by converting it to what? To mils. Now this here and this will go. So we are going to have your your what? Your 15 mils here. This is the end.